And now they also switched to mellow.
Okay, there are some questions about one of the homework problems. So let me go through page 14. The question was about cross section for part C. Part C says for the solid S given in part B, find the average value of the area of the cross section hooked into the x-axis. And it's like, well, how do you know what the cross section is? Is it a square? Is it a triangle? Is it a is it a semicircle? Like it feels like as if we're not getting enough information about cross section. Now remember with cross section problems, the formula is this: B is equal to the integral of the area, whatever the area is, dx or dy, right? And the area can be a rectangle, it can be a square, it can be triangle, it can be a semicircle. But it feels like as if we're not getting enough information about the area that is provided. However, if you think about part B here, this method, the fact that this is being rotated, what shape is getting created here? Circle. So they're just wording it a little differently. Rather than saying a circle area, they're they want students to connect the fact that, oh, this method is circle, and so we're doing a circular cross section, right? This method and washer method are both circular cross sections. When we move into cross section portion, then we usually talk about shapes other than circles. But here, they just want us to continue with that idea that we're using a cross section for circle area. So then pi r squared, that goes in here. So pi r squared is going to go, instead of base squared or 1/4 base squared if it's a triangle, they just want us to use that pi radius squared. So once we get that pi radius squared into our integral, then they're asking for the average value. So we put 1 over b minus a in front of it, and then we just go through our process, our integral process, and evaluate. For part D, we can still evaluate that 1 over root x. We go through power rule, we plug in upper and lower bound, but in this case, my b is in the numerator, so we know it's going to push out to infinity. But for this next part here, if it's 1 over b minus 4, from 4 to b, 1 over root x, we're going to get this result, which is actually going to lead us to 0 because the denominator b is growing at a faster rate than the numerator b. That's compared, well, yeah, so degree 1 is growing at a faster rate than square root. So that's going to go to 0, which converges. Yeah.
It gives a different shape for the cross section.
Yes, sometimes they would do it, but then those problems would be like a separate problem where it's like a cross section using the same function but building a different area. But here they say use a cross section from part B, so we just have to need to connect. Oh, this method, that's a circle. Yeah, but yeah, I know it's worded a little differently because typically we associate cross sections with shapes other than disc or washer method.
Okay, today we're going to work through page 15 through 19. Before we do that, I just want to show you what you picked up here. This is just a formula sheet. Hopefully, this will be a useful formula sheet as you guys are preparing for the AP exam, and also a good way to kind of help organize all the information that we've learned this this past semester as well as first semester. So what I just want to show you how I organized this. I organized this. This is unit 6 through 8 first. All the topics from 6 to 8, and then I put the polar parametric vector formulas bottom half, and then the second page are all the unit 10 summary here. So you got test for convergence, which is 10.1 to 10.6, and then second half is infinite series and all the formulas involving with infinite series. And then I moved into the AB portion, pages 3 and 4. And then the rest, pages 5 through 13, are just more summaries, but also I provided some blank copies for in case you want to eventually kind of practice all the formulas that we've learned between our 2 semesters here. So yeah, so hopefully this will be a good one. If you guys can add a couple of things though, after I printed it out, I realized there were some things that some details that I can provide for some of these. So integration by parts are the priority order that we use for determining what our F function is. It's going to be that LIATE. L for logs. We really don't involve inverse trig, but really it's logs, algebraic, trig, and exponential. Whichever comes first in the acronym is going to take the it's going to be the one that you're going to assign as F. So basically, if you're doing integration by parts and logs is showing up, your log is always going to be your F. And then logistic differential equation, we have 2 different forms. And but in either form, L is your limiting value or your carrying capacity. It's the largest that the curve is going to be able to reach. And then the max growth is occurring at that point of inflection, which is when L divided by 2. That's going to be that Y value. So we want to add that in to your formula sheet. And then one more thing, as I was doing a help session this morning, I think this is also helpful. On page 3, when we're dealing with limits, especially limits as we approach infinity, and we have 2 different pairs types of functions. You go through L'Hopital's rule, but sometimes a little faster than L'Hopital's rule is using comparative growth rates. If I have logs over a radical, or if I have a polynomial over an exponential, whichever is growing at a faster rate in the denominator is going to either numerator or denominator will either push the expression to be either 0 or infinity. So if the higher growth function is up top, it'll go to infinity. If the higher growth function is below, it'll go to 0. And logs, if we're going out to infinity, then logs will always grow at the slowest rate, followed by radicals, followed by polynomials, and exponential grows at the fastest rate. So the acronym there is LRPE. And then also, I know that page 15 was your homework, but just want to kind of go over what a logistic differential equation problem could look like. We know that this is in that logistic equation form. You know that 12 is matching this this formula here, and we know that that L value is going to be telling us our maximum capacity or carrying capacity. And then for what value P is population growing fastest, it's going to be at that point of inflection, which is at L over 2. And we know that's 12 over 2 is 6. So these are, as far as logistic equations go, just really just you identify that L value and you know that the growth is fastest at that L over 2. Okay, any questions? Page 15. Okay, let's try page 16. Area is just top graph minus bottom graph. This is meant to be non-calculator, so I want to see your work. You can skip U substitution if you know that your U value is only going to produce derivative of 1. So that's why I saw that. That I knew that the 1 over x plus 2, which is 1 over u du, which is natural log of absolute value of u. Part B, we're taking that region R and we're rotating about our axis. We know there's no gap, so this method. But after U substitution for this method, this is no longer going to be a natural log. This is going to be now set up as power rule. It's no longer 1 over u to the first power. It's 1 over u to the second power. We got to go through a power rule for our antiderivative. Part C, we have that now moving into improper integrals because let S be the unbounded region in the first quadrant to the right of the vertical line, x equals k, and below the graph of f. Find the value of k such that the volume of the solid generated when S is revolved around the x-axis equal to the volume of the solid found in part B. So we're going to go from k out to infinity, and we're going to see if this can actually converge. Maybe it's decreasing at a fast enough rate where out to infinity, it's actually headed towards some ceiling. And so we have to set it up from k out to infinity. And this is going to be improper integral here. We still go through power rule. We just have to hold on to our, let that upper bound be b, and see if and we know that this is going to get us down to pi over k plus 2. We want this to be the same as this, right? We want to find the k value where these are equal. So then we can set these two volumes equal to each other and help us solve for k. If we go with 16, go to 17. Sorry.
The polar effect is always calculated.
Usually, but they can also adjust it where it's non-calculator. But if it's non-calculator, they have to make everything nice and easy to find, or they give you enough information so you don't have to use the calculator. But yeah, I would say it's about equal in terms of the show up on non-calculator calculator. Yeah, polar is not guaranteed to show up on the FRQ section. It will definitely show up on multiple choice, but it's been a few years since it hasn't shown up, so maybe this is the year.
How do you know when to use this measure method or washing liquid? Because like sometimes I can change the piece.
You look to see if there's a gap. If my shader region looks like this, it's a flat surface up against dotted line, then this is this. But if my shader region is touching, but it's obviously up against a curved region, if there's any sort of a gap or a hole, then it's gonna be a wash. So flat surface of the shaded region up against the dotted line, that's this. Not a flat surface up against the dotted line, that's the washer.
Whenever as for area, we just have to do top and spot.
I would always start top minus bottom. That should be your default. If that doesn't work, then you'll do right minus left. But usually if it's right minus left, your equation will be strange. It'll be like x equals y squared minus 4y, something like that. But yeah, if it's area, we should always, our default should be top minus bottom, unless told otherwise. On page 17, you're starting off part A with solving a differential equation. I set parts B and C equal each other, and I solve for K that way. So part B is this method, part C is from K to infinity, also this method. This is good. But yeah, this. All right, page 17. For part B, if it's a logistic differential equation, all your curves will look like this, will always be shaped like this, and they'll always be heading off towards they'll always be reaching a ceiling.
Okay, great. Great. I'll mark it down. Thanks. Yeah.
Why don't we just make, the equation when we simplify to minus 3 and set dy dx as f dash x, and then when we integrate it, that would be fx is equal to integral 2y times 3 minus 1.
Remember, if you're trying to find antiderivative and your variables are not separated, we first have to go through separation of variables. What you're saying just do power rule for each of these separately?
No, why don't we just use the equation that says 2y times 3 minus 1? We'll just oh, because it's saying half equation.
Oh, 2. Yeah, they're asking for a G. Yeah, so the first equation is involving F, the second one is involving G. Okay. Page 18, unless you have any questions.
Will be 0, right?
Say it again?
At point of inflection, the second derivative would be
Will
0.
be 0, right?
But if I was to use the first derivative, the only way to tell it would be to see where it goes from positive to negative, correct? If I was using the first derivative to tell,
Oh, first order test. Yeah. If you don't find relative max, relative min using first order test, you gotta look at the signs on both sides of F prime. But if you're using the second derivative test, first confirm that your F prime is 0, and then F double prime, if it's either concave up or concave down, you can use that to narrow it down whether it's a relative max, relative.
can you use first to determine point of inflection, or you have
Now,
to take?
first derivative is not going to give you anything about curvature.
No.
No.
Okay, go ahead and start page 19, if you're ready. Okay, so again, your quiz tomorrow, 2 FRQs, one polar area and one miscellaneous topic FRQ. No help session tomorrow morning. I'm doing one for my AV students. But bring your calculator. I'll send a reminder this afternoon. On Friday, I'm going to be checking the rest of the packet. We're pretty much done, so I'll just be checking pages 16 through 19. And then we'll need to start looking at multiple choice in preparation for next Tuesday's test, which will be AP topics, 15 questions, multiple choice, first part. Okay, all right, come get your phones.
So. Hold on. Oh, okay. I was just saying, I'm surprised that you didn't show up.
Yeah. Right. Guys, the rest of the packet, page 19 through to 28, those are not going to show up on the tomorrow's. Those are not focused for tomorrow, right? It's just that's for extra packet. Page 20 on are not are two topics.
Oh, yeah. That's good. He's been first. Like you're, you see.
Yeah.